Um, hey, so what I have here is iodine, and you can tell it's solid at room temperature, which is kind of curious. It's I2, and I put a couple days ago put some iodine in water, and you can tell that the iodine dissolved in the water. So iodine, thinking it's I2, is nonpolar, doesn't have a dipole, and water, it being polar, you wouldn't think it would dissolve, but certainly does. You can tell by the color. So let's think first of all, how's iodine attracted to a water molecule? So if you think about water, we know it has a dipole. Oxygen's more electronegative than hydrogen. This is partially negative. Hydrogen's partially positive. This whole part's partially positive. Then this iodine, this is I2, right? Iodine has a whole bunch of electrons. Let me put the valence electrons here. So think about what's that partial negative do? How do the electrons in this molecule react to this partial negative? Yeah, they're repelled. Likes repel, right? So all these electrons. Iodine, each iodine has 53 electrons, so it's really polarizable. That's a nice word, huh? So what we do is we're actually making this have a dipole. This is partially positive. We're going to push a lot of electrons to this side, making this partial positive, and then they'll attract. The positive and negative attracts. And this is called dipole induced dipole. All right. So that's not the neat part. That's part of this lesson. So let's see what happens with this. I'm going to pour some of this iodine water into this separatory funnel. It's a sep funnel. We don't use this in an organic, but we use it in organic. Now I'm going to use cyclohexane. I'm going to pour cyclohexane. You have to know cyclohexane, C6H12. It's a hydrocarbon, nonpolar, less dense than water, so it's going to stick. It's going to stay right on top of the water. Water's not going to want anything to do with it. So let me pour some cyclohexane into this. Stays right on the surface. And now what I'm going to do is behind my back, I'm going to shake this up. I'm going to shake this up, shake and vent it. So everything has a chance to like knock into everything else. So the iodine's knocking into the cyclohexane, water molecules are knocking into water molecules knocking into iodine. So so why don't you pause this video and think about what's this going to look like. And I'm going to continue, hopefully you can't see this, I'm going to continue shaking and venting. So, all right, so hopefully you've thought about this, and what we have is we have a little emulsion, but this will clear up a little bit. So you can see this is a little emulsion that formed. It's going away. So you can see that the cyclohexane extracted the iodine out of the water. Think about a dentist extracting a tooth, pulling it out. So the iodine went into the cyclohexane. So it's curious as to why that is. So you think about water molecules attract each other by what's called hydrogen bonding. So when we shook this up, the water molecules stayed together and just pushed all the iodine away. And so the iodine had no other place to go except for the cyclohexane. And it's certainly soluble in cyclohexane. This is an extraction of iodine using cyclohexane. We could use any non-polar solvent. Anything that's immiscible is fine. Okay.